The congruent statement on 9C.
Okay. Let's look at 9C's out of order, you think?
I think you did the wrong one.
I did the wrong one.
I
Okay.
think you did the first one.
Sorry, maybe copy something or something like that.
Yeah.
That's entirely possible. AMN. I copy pasted, didn't I? I just didn't fix it, did I? Yeah. So clearly I did not do that. All right. So as we can see here, Eva pointed out, I copy pasted the congruent statement to letter C there. It is definitely not the same. So looking at this though, real quick, at the end of this period, we're going to again have a short 6-question mini quiz. On that mini quiz, all you're going to need to do though is you're not going to have to worry about writing the congruent statements. All I'm looking for is, can you tell me if it's congruent by SSS or SAS? That's it. Like I said, it should be no more than like 3 minutes. If it's taking even more than 3 minutes, you really don't know what you're doing then. So it should be relatively quick. All I'm looking for is ASA or SSS, ASS. Please no ASS. Don't be an ass. All right. So that's all I'm looking for. Okay. But yeah, on 9C, I copy pasted wrong. So matching up the correct parts there. All right. What do we got? Left side, however you want to name it, I don't care. Triangle ABD, cool, whatever. But now that you've locked in that first triangle, you've now locked in the second one. Yeah, is that cool? Should we open it, guys?
No.
No.
We always say no.
I know, that's me.
All right. So ABD, and since we locked in ABD, what do we have for ABD? ACD. Okay. Again, that's just one of the suggestions. All right. If you named it a different route, that's fine. Just make sure your corresponding parts are matched out. Yeah, I think we're just going over homework questions. Okay. All right. Other questions, Brianna? What's that? 5. Okay. Let's take a look at 5. Let's see, where's 5 at? This page. All right. Number 5 with our numbered angles. Several things going on there. All right. First thing, it does. Sometimes it matters what angle you find first. This one, maybe not. But for me, I noticed that diameter. Those diameters again are always those silent things. And when I see that diameter, I notice one of these angles goes right back to that diameter. Tracing it out. Angle 1 is that diameter, is that inscribed angle with it. And because that diameter gets me what? 180. Inscribed angle gets me angle 1, which is 90, right? There's 1. Angle 2. Angle 2 is an inscribed angle, and I like to keep tracing. Angle 2, when I trace out angle 2, when I trace it out, it's inscribed, and it traces to that arc right there. It traces to 40. 40 is the arc, therefore angle 2 is what? Yep, it's half of it. So 40 is half of that is 20, right? Now the last one there, angle 3, again I trace it out. Angle 3 is another inscribed angle sitting on the circle. Trace it out. Okay, I trace it out. Now when I trace it back to this arc, I see it's this blue arc right here, which I got nothing on. Okay, but back to that diameter again. Diameter cuts us into 180. Here's that 180 right here. This is 70. So what's this remaining part? 110. So I've got a semicircle right here because of that diameter. That's 70, that's 110, that's that 180. One more time, arc to the inscribed angle, that is half. So that's where I'm getting that 55 from, okay? Again, it keeps coming from practice and practice and practice. Trying them out, trying them out, trying them out, okay? Anything else anybody's got? Yeah, next door there. And first thing I notice is on that next door, there's another diameter. That diameter, and it creates me these two arcs. And because of that diameter, creating then a semicircle with these two arcs, there's that 180 right there. So very similar to what happened on that last one with that 70 and that 110 making 180. Same idea is happening there. So again, focus on those diameters, creating semicircles, and that's the equation I've got going right there. So on that equation then, you should be able to solve that equation out, okay? Assuming I solved that out right, nobody called me out on it yet. So x equals 3, okay? So if x equals 3, we got the x then. It also asks you to find those two other things. So we solved out for x is 3. Now where is arc GH at? Arc GH is this 35x plus 5. You've locked in x is 3, so let's go to that calculator and plug it in. You've locked x is 3, so 35 times 3 plus 5. Calculator says, I think 110 hopefully. Angle, GFH, trace it out. That's all that angle work we've been doing. Trace out GFH. It happens to be an inscribed angle. We just found that to be 110, that arc that it goes to. And because that's 110, half of 110 is, there we go. Okay. Anything else people got? We're going to do more work with it. Again, it's not something I expect mastered even by the end of this topic. These are going to fall into the next semester as well. They're going to keep following you through. Okay. All right. We're going to continue our work with quadrilaterals today, and at the end of the period, we're going to, like I said, do that short mini quiz. Nothing fancy. It's just going to be, like I said right here, not worrying about the congruent statement. Just tell me what shortcut did you use. Those are your options, okay? So let's make sure your name's on that. Throw it in the basket. Let's get those notes out. Let's try to wrap up these notes as quickly as we can here today. And let's see where we're at. I'm not sure what page we actually left off on. I think we left off on 220. Page 220.
Sure.
Sure. 220. Try and roll through this relatively quick here so we can go through these, I think, last two quadrilaterals. Well, 3 as well. All right, as quickly as we can here, page 220. Okay. And as we've been doing, we're going to do it one more time. Use that padding paper and make that perpendicular bisector. Okay, page 220. Let me go find that right page. Set it. Okay, and make that one more time. That perpendicular bisector on that padding paper that we've done. And after you 220. Okay. We're going to draw that in, and we're going to only connect it on the inner circle. So yesterday we did these concentric circles, and we're only going to do it on the inner circle. So when you draw that, we've done the perpendicular bisector. It bisects that segment BC. It then is going to be perpendicular. So we're only going to do it right there. And this time, we do want to use that diameter of that inner circle as FG. So we're not going to draw a secondary diameter in there. We're going to go with that as is. And we're going to call that FG. And because it's perpendicular, it's throwing that right angle. And we're going to build our next quadrilateral right here. So let's connect all those vertices right there. Okay. And B to F, F to C, C to G, and G to B. All right, all right. BCFG. Those are our diagonals. Those are the three things, or sorry, those are things that we want to keep keep an eye out for, if I can speak. And there are three things, as I was trying to say, we want to keep an eye out for. Are they bisecting one another? Are they congruent? Are they perpendicular? Okay, can we mark up those three things? Okay. So the square got them all. Rectangle, I think, got 2 of those. Parallelogram, I think, got 1 of those yesterday. What do we have here? What can we mark up? So as we look at what we've got going here, this appears to be bisecting. Okay. And again, the reason why we can say we're bisecting here is, well, what we've got going here is they're intersecting at this central point, this circle, or the center on both of these concentric circles. And as this BC comes in, it does cut in half that diameter FG. So we get 2 congruent radii. That's happening. And then the same thing happens for the other diameter. FG is then cutting up the other bigger diameter, BC. So we got 2 other congruent radii. Now, the follow-up question is, and it should be an obvious answer, are the 2 diameters congruent to one another? Are the 2 diagonals congruent to one another? No. But what we have happening is, as Eva said, they are doing what to one another? So we do know that they are bisecting each other. They are bisecting each other. And what else are they also doing? We're using the perpendicular bisector on that one, so they are also perpendicular. So let's go ahead and state out that FG is perpendicular to, what is it? BC. But clearly, as we can see, they're using diameters of 2 different circles, so those diagonals are definitely not congruent. I'm hoping you definitely see that. Okay? So this one gets 2 of those 3. Now let's think about the quadrilaterals we have not talked about yet. And what's the other one we haven't talked about yet? Both sides are the same. Talked about square in the first day. What's the other one with all sides the same? Oh my god. All sides are the same. Thank you. There you go. We haven't talked about a rhombus, and there's one more we haven't talked about. Trapezoid. We haven't talked about yet. Okay. Now, we've talked about our flow chart. We've talked about our family tree, and that parallelogram is one of them at the top, right? And so is a trapezoid. That trapezoid is the odd dude, I always think. Kite's also a weird one. We're going to see that here. It's not a kite, though. Kind of looks like a kite. But what we've got going here is the start of the rhombus. Okay? And where does this rhombus come into play? Side angle side again. Right here, we're going to go back to our triangle congruences. We're going to mark up all 4 sides right now. They're all congruent. How are we going to do that? Right here, where you've told me they're bisecting one another and they're perpendicular to one another. If I take this triangle off to the side and bring in my triangle congruences, isn't this happening in all 4 of these triangles right here? And that matches up to SAS, right? So by SAS, what is true about every single of these sides of the triangle then? The hypotenuses of these 4 triangles. They're all congruent. And what type of quadrilateral do we now have? We have ourselves a rhombus then. Okay, that's not a kite. The thing is that we're trying to deal with is we're not 100% sure on our shapes from prior knowledge. So a kite is slightly different than a rhombus. They look kind of similar, but they're not. So this is a rhombus happening because all 4 sides are congruent, right? So we get ourselves a rhombus hiding here. And a rhombus does those 2 things, which kind of makes sense. For a rhombus is underneath of a parallelogram where it's bisecting one another. yesterday in our parallelogram, we said the only thing that happens in a parallelogram was this right here. It bisect one another. And then the day before, we said the square does all three things. It bisects, it's perpendicular, and the diagonals are congruent. Well, the diagonals aren't congruent here, but where were the diagonals congruent on the other quadrilateral? It was congruent on a what? Just silence is killing me. What was the other shape we identified yesterday? Parallelogram we did, and the other one was a rectangle. And what does a rectangle and a rhombus make? Rectangle and rhombus make a square. So here's where the perpendicular diagonals help make a square. This is coming from the parallelogram down to the square, and then the rectangle is bringing in the congruent diagonals then, okay? All those pieces are working together to make the square then, okay? So here's what we've got now. We have, yes, this is happening by SAS, and we did this, well, we didn't do this here. Okay, we haven't talked about the angles. The angles of a rhombus, if we were to get out the protractor, I cannot think of that word in my life. If we got the protractor is going to have the same properties of the parallelogram we stated yesterday, because it's underneath the parallelogram. And what that means is, if we look back at our notes from yesterday, is that the opposite angles are congruent. Okay, that's really about all we're going to say about the whatchamacallit, the rhombus. You're going to see that the opposite angles are congruent. That's really about what's happening there. Okay. And then what shape do we have here? We have ourselves a rhombus. And if we're a rhombus, what else are we above that? We're a parallelogram. And if we're a parallelogram, we are a trapezoid. And if we're a trapezoid, we are not a triangle, right? We're a quadrilateral. Okay? All right, let's roll it. We've knocked out rectangle, square, parallelogram, rhombus just now. We have two that remain, a trapezoid and a, thank you. Wait, what did we just say? Quadrilateral, it's the one, kite, thank you. I forgot the one, kite. Kite's the one that doesn't come up quite a bit. So let's take a look at the kite. That's the next one, which students kind of confuse with the rhombus. And the one word I haven't talked about yet is a diamond. Diamond's not a mathematical term. So my daughter came back, she's in 4th grade. At the beginning of the year, her teacher used the word diamond, and Mrs. Dresch and I kind of threw it. So it's not a mathematical term. When we say a diamond, I don't know what you mean by a diamond. So a diamond, I don't know. Most people, when they say a diamond, probably are referring to a rhombus, but I could also see somebody saying it's a kite. So rhombus or a kite, it's one of those two, I guess. But it's a rhombus, okay? So let's go look at a kite now. We don't throw a fit, we just talk to one another, yell at one another. Go throw a fit, we're not that. Okay. So we're not those type of parents that go and throw a fit in school. We just yell at one another. All right. So let's get going here. Do the same thing. Let's go do that one more time here, guys. This will be the last one I promise you we do that on. Okay? Let's go make that perpendicular bisector. And this time, as we do that, we're going to go ahead and make it a little bit longer here, where we're going to draw that as you put that crease on there, and we're going to draw that from the diameter of the inner circle and extend it a little bit further down into the bottom circle. Okay? And that's perpendicular to the to that diameter BC, that diameter BC. This is going to be our last one, which is again a kite. Now, connect it out, or let's label it out. We're going to label that out H and J. And And let's connect it out now. Now the kite is also kind of an odd one. As I kept talking about my family tree the last few days, I have not put a kite at all in our family tree, really have I? Biggest one we usually focus on is parallelogram, rectangle, rhombus, and a square. The kite does kind of fall off to the side, all right? Because it really doesn't have anything to do with parallel lines. Those other ones all have to do with parallel lines, right? A kite doesn't have any parallel lines in there on the sides. So that's where it's kind of the odd man out. So let's talk about this kite. Let's focus on these diagonals one more time. As you look at these diagonals, okay, H, J, and BC, okay? What can we for sure say about these diagonals here? The diagonals are doing what to one another? Crossing, but intersecting such that they are perpendicular, right? We can clearly see that the way we've created this, they are perpendicular to one another, okay? So BC is perpendicular to what? HJ, okay? Do they appear to be congruent? No, they're not congruent. If they were going to be congruent, to move that, say, like up or anything like that, to be congruent, we end up with back to like a rhombus. Okay, so we're not congruent there. And there is possibly an instance where they could be bisecting but not each other. They could bisect one or the other, but not each other. So in this instance here, where is one bisecting? HJ is bisecting BC, right? So as we look at this here, HJ is coming in and bisecting segment BC, right? So you can see that this HJ, this is the diameter of this big circle right through that center. So that's happening. But I'm not going to say mark up that they're bisecting each other, are they? The one's only bisecting the other. And that's all we can really say, okay? All right, that's about it. Now, after that, that's really kind of all we've got to say about the diagonals, is that they're perpendicular to one another. That's it for a kite, okay? Now, so we can finish this up here today. The other things about a kite is this here. On a kite, these two sides are congruent to one another, and these two sides are congruent to one another, okay? So in a kite, we have two pairs of adjacent sides that are congruent. These two adjacent sides are congruent to one another, and those two sides are adjacent to one another. So we have two pairs of adjacent sides, okay? That's really about it for a kite. I want you to remember that the diagonals are perpendicular, and you have two pairs of adjacent sides that are congruent. That's about as crazy as we're going to get with a kite, and that they're perpendicular, okay? That's about as crazy as we're going to go for a kite. All right, let's flip it. Let's talk about the last shape that we haven't talked about. Last shape we haven't talked about is a trapezoid. And actually, trapezoid is not anything really too crazy in itself. It's not really too interesting. The one that is the interesting one, and really interesting is relative because it's shapes really aren't interesting, are they? Is the isosceles trapezoid. So we're not going to look at just any old trapezoid, we're looking at the isosceles trapezoid. And they must not consider it too interesting because they didn't give us our patty cake figure with it. So we're going to mark it up. Isosceles trapezoid, any trapezoid in general. There's finally that parallel lines again that we've been talking about that starts our flow chart. Now, that's just for every trapezoid. And that's really about it. But once we get into a very specific trapezoid, which is the isosceles trapezoid, that's where we have a pair of, then the sides are congruent. We call those sides that are congruent, we call those the legs, okay? Those are the legs of the isosceles trapezoid. The parallel sides of the trapezoid, those aren't the legs. We call those the bases. Base and base. Okay? So, in the isosceles trapezoid, they do get some special names. Legs and bases. Alright? In that isosceles trapezoid, okay, we got our diagonals. Alright? They intersect, but there's not much more going on with the intersection with the diagonals, but there's one thing that does go on with them. We've got three things that we've been looking at. Congruent, perpendicular, and do they bisect one another? Anybody want to throw out what you think is happening here with the diagonals of the isosceles? Congruent. If we were to take our patty paper, all right, and maybe throw these two triangles here together and put one on top of the other, you're going to find out that these two diagonals, they're congruent. So the TZ, which is that first and that second diagonal then, TZ is congruent to PD. That's about it for the isosceles trapezoid. That's only true for the isosceles trapezoid. They don't bisect one another. They just are congruent. Okay. All right. Cool. That does it. That's finally wrapping up our whatchamacallits, quadrilaterals. Now we're going to come back to the quadrilaterals here in a couple minutes, but before I do that, so we don't run out of time, we're going to. Okay. So we've got our quadrilaterals up there, and as you can see, we're not saying just a trapezoid. We're talking about the isosceles trapezoid. So that's the one that we usually do. Let's go down here really quick to the diagonals, because those are the ones that we've really been focusing on the most with. So of the quadrilaterals, which ones did we say do the bisecting of each other? And again, I always try to think about that family tree. So maybe off to the side, it might be helpful to kind of have that family tree there. And together those two make a square. Now the kite's again kind of the odd one there. The kite just kind of, it in the different family trees I've seen, it kind of floats off to the side, close to the rhombus. And the reason why it floats kind of off to the side next to the rhombus, I'll talk about here in just a second once we mark it up. Okay? But that's kind of how the family tree happens out. All right. What do we got? Does a parallelogram do that? Bisect each other. Yeah, we saw that yesterday. And that's where I want to keep that family tree in mind, because once you say a parallelogram, everything below a parallelogram happens out. And what's below a parallelogram? Rectangle. Oh, sorry. I was thinking something else. I'm totally bad. Rhombuses and a square. Okay? So rectangle, rhombus, square are all below parallelogram. Now, did the other anything else do that as well? Did the isosceles trapezoid do that? Nope. And a kite, did we say a kite did that? No. Diagonals are perpendicular. Parallelogram did not do that. Did a rectangle do that? That was yesterday. That did not. Today was a rhombus. Did a rhombus do that today? Yes, it did. A rhombus did do that. Now, because a rhombus did that, what is below a rhombus? So square is going to do that then. Anything that's below it's going to do that. So square is below that. And did a isosceles trapezoid do that? No. Did a kite do that? Yeah, a kite did do that. A kite did do that. And that's the reason why a kite is usually kind of hiding off to the side here, closest to a rhombus, is because it does have that relation with the perpendicular diagonals. Okay? Diagonals are congruent. Okay. Did we say a parallelogram did that? No. The only thing we said about a parallelogram was this first one. And then as you got more specific with the shape, we ran into a rectangle. That was where a rectangle did that. Rectangle had, what did we just say? Congruent diagonals. And then everything below rectangle has that. And what's the thing below the rectangle? Square. A rhombus did not have that. A rhombus did not have that, because if you said that for a rhombus, all of a sudden you've got yourself a square then, which we don't have that there. Did an isosceles trapezoid have that? Yeah, that's the one thing that the isosceles trapezoid had. And did the kites have that? No. The only thing the kite had was perpendiculars. Okay? So those are really where I want you to be at, is knowing about the diagonals. Okay? Now, coming back round, up at the top on some of these things about the side relationships, opposite sides are parallel. That should be a given. You should know about what's happening there. Opposite sides are parallel. Okay, parallelogram. Is that happening? Most definitely. Most definitely. Everything below that then. Everything below that is parallelogram, rectangle, rhombus, square. Does an isosceles trapezoid do that? No, that's only one side. And is a kite doing that? Not at all. Only one pair of sides are parallel. Trapezoid. Opposite sides are congruent. I'm sorry? Square. Rhombus. Anything else? Opposite sides, what we just say? Square and a rhombus. Opposite sides are congruent, and this one's kind of phrased. Yeah, and I was just about to say, you can, opposite sides are congruent. You could say rectangle, because the way it's phrased is not phrased great. Because down here it says all sides are congruent. That's a little bit more clear. When we say all sides are congruent, that's clearly stating what? Square and rhombus. So when you say opposite sides are congruent, if you said those two as well, that totally makes sense. You've got two pairs of opposite sides congruent, right? In a rectangle and a rectangle parallelogram. So I would totally buy that. Isosceles trapezoid does not. It only has one pair. And a kite, those are not opposite sides. Those are what we call adjacents. Only one pair of opposite sides are congruent. That's the isosceles trapezoid. That is correct. And I think that's the only one there. All sides are congruent. That is correct. The rhombus and square then. That's all I think we can do there, right? Okay, that's the weird phrasing on the next one. Two pairs of consecutive sides are congruent. And that consecutive is another way we can say adjacent. That's my kite. Okay. Now, getting into the interior, some of the angle work we did. Well, the easiest one to talk about real quick is all angles are right angles. What's the all angles are right angles? Square and rectangle. Yep. Okay. All right. Opposite angles are congruent. That might be one we have to look back at our notes and see which ones we said opposite angles are congruent. And I believe we said that on the parallelogram, that's where it starts off at. So on the parallelogram, opposite angles are congruent. And as soon as we remember, if it's happening on a parallelogram, it happens every place else below that. Which makes sense. In a rectangle, what's the opposite angles of a rectangle? 90 and 90 and 90 are congruent, right? That makes sense. Same thing in a square, but if it happened in a parallelogram, even though it's a rhombus that we're not like 100% sure on what about the angles are, it's got to be happening from a parallelogram. In an isosceles trapezoid, all right, I'm drawing a blank actually. Let me double check that one. Because I don't know if I said anything about the angles, the adjacent angles, but not the opposites. Okay. And then, yeah, that's not. And then the kite, those are not as well. Lastly, at least one pair of opposite angles is congruent. That's a phrasing. That's weird. At least one pair of opposite angles is congruent. So when we say the word at least, that's going to check off a whole bunch of those, isn't it? So that's going to get us those first four again, aren't they? At least one pair. That has at least one pair, doesn't it? Now what that at least one pair does gets me one more, actually. It's going to get me into the kite, actually. That's going to get me into the kite. And where that gets me into the kite, if I go back to the picture of, if I can find my kite from someplace. Okay, where that gets me into the kite, the angles that are going to be congruent are those two right here, B and C. Those are the two that are going to be congruent then. Okay. All right, I will now shut up for you. Give you some time to work. You got about 10 minutes, right around there. What's that? Okay. Give you guys some time to work then.